All right, guys, welcome to your first lesson for college algebra. This is coming out of the back of the book, the appendix. It's basically the whole appendix is an algebra review type thing. Like I said in class today, a lot of this course is not only a review of Algebra 2, but also an extension of it. So tonight is more kind of review stuff. Some of you guys may find that. Other of you guys may have been a while since you've seen these things. So we're going to get the gears moving again and get back to doing math every day. So first thing, quick little recap of the whole real number system, just because it's always interesting to look at and discuss. So first thing is the natural numbers here. You don't need to copy this down, just to get a visual idea of where we're coming from, the different things we're studying. So when people much smarter and much older than us started inventing math, they said, okay, things occur naturally. I can count 1 things, 2 things, 3 things, etc. These are naturally occurring. But then they had to come up with this idea, the concept of 0. 0 doesn't naturally occur, so they called those the whole numbers. Then they moved on with integers for negatives. So they needed negatives for things like negative temperature or to show debt. Okay, you owe me money, or you owe me land, or you owe me cattle, different things like that. After you get all of the whole numbers, you get into the rationals. And we know a rational is anything that you can write as basically a fraction. So the 4 of these things here, all examples of rational numbers. You know, this would obviously be negative 4.5. Even though this has the bar there and it keeps repeating, we can still write it as a fraction. Obviously 11.23, you know, we could as well. And then, you know, this is 0.75. So the only difference between rational and irrational is irrational numbers can't be written as a fraction. So we all know pi is 3.14, and then it just keeps going and going and going. You can't write that as a fraction. You can get really, really, really close. I think it's like 22/7, but you're never going to exactly hit pi. Same thing with e here, 2.718, and square root of 2. You can't write that as a fraction. Okay, those are the differences between them. First thing, just quick little recap on substituting variables into expressions. So tons of choices you can have for the expressions, all kinds of different things for the variables as well. So I just came up with a simple little problem here. Let's say x is negative 10, y is 2. We're just going to throw those into the appropriate place and figure out what happens. You know, whatever comes out of absolute values always need to be positive. So negative 10 plus 6 is negative 4, but the absolute value is going to make that positive here. So your answer comes out to positive 1/4. Make sure when you're doing these, you always reduce your fractions, take care of your negatives, different things like that. Okay, so you guys can expect to work on some simple substitution things. Next, now this is a topic that you touch on in Algebra 2, but something we're going to hammer a lot in college algebra, and it's this whole idea of domain. Now, it's a difficult concept to grasp, so within this class, like I said, we're going to hit it a lot, so I think it's easier to think of it as this definition. What x can or cannot be, not some fancy mathematical thing that you have to try and interpret. Okay, so what can x be or what can it be? So when we say can or can't, think about things you can't have in math. You can't have a negative square root. You're not able to do square root of negative 9. Okay, some of you guys may say, well, that's an imaginary number. That's going to be 3i, or a complex number. We're stuck in the real number system here. Okay, that's why I showed you guys this. So we can't have negative square roots, and we can't have zeros on the bottom. If you don't believe me about the zeros on the bottom, see what your calculator says. So try 9 divided by 0. It's going to say error divided by 0. Okay, so those are basically the 2 things right now we're going to try and look out for. Okay, 5 different examples here for you guys. Okay, so what can x be or what can it be? If you look at A, There's no square roots. We don't have to worry about that. There's a 5 on the bottom. No matter what you plug in here, it's going to give you a real number, an okay thing mathematically. Okay, you can plug in a 0 and you get 2/5. You can plug in a -5 and you get -3/5. Okay, that's allowed. Anything you want for x is allowed. Okay, an easy way to say that is just all real numbers. Now, some of you guys may have seen that sign before. It's kind of the R with like the double space there. That represents all numbers. Now for B, all I did was take the reciprocal of that previous expression. Now here you run into some trouble. If you look at this x on the bottom, if you plug in a -2, you get 5/0. Okay, that's not allowed. If you plug in -2.1, you get a number. That's okay. If you plug in -1.99, you get a number on the bottom. That's okay. So you can have any number you want except a 2. So the difference is you care about things on the bottom, not so much on the top right now. So for part A, it was easier to say x can be anything. For part B, it's easier to say what x can't be than the infinite things that it can. So in this case, x can't be a -2. It can be anything else but a -2. Next one, part C. So an x plus 2 over an x. Again, you don't really care about the top. You can plug in whatever you want here, and that's going to be okay if you ignore the bottom. You can plug in a 0, you can plug in a -2, all that stuff. The problem comes in with the x on the bottom. First thing is, kids are always tempted to do this and just say, well, it's just 2. It doesn't work that way because the x gets split up between both of those things. So if you were to do that, you actually get this, which becomes 1/2 over x. Okay? So first thing is don't just cancel those x's out of there. Kind of a pet peeve of mine. Algebra rules we don't want to be breaking. So again, let's just look at the bottom. So what can't x be? What can't you have? You can't have a 0 on the bottom. So even though we can have a 0 on the top for this, if you put a 0 on the bottom right there, you're going to run into trouble. Okay, last two here. Same idea, an x plus 2 on top. Honestly, we don't even really care what's happening on top right now. Okay, anything you plug in there for x is going to be fine. So we're not going to really worry about that. Make sure we're not going, oh, x cancels there. Okay, that doesn't work either. You can plug in some numbers and see why. We're focusing on the bottoms right now. When you see something that's an expression that can be factored, we have to take care of that. So we're going to do a lot of factoring this week. So if you haven't seen these in a little bit, this is a difference of squares. X minus 3, x plus 3. The middle terms would go away. Now, if you plug in a 3, this term goes to 0. If that term goes to a 0, 0 times anything is 0. So if either one of these two terms go to 0, you're in trouble. So in this case, we have two things that x can't be, 3 or -3, because that's what turns each of these respectively into 0. Last one. Again, don't just start doing stuff like that. Okay, it doesn't work. You're not allowed to. We don't really care what's happening on the top. We're going to look at the bottom. Again, we see an x squared and an x. You guys should recognize that's a GCF. For whatever reason, those are kind of, they're simpler factorings, but students don't always catch those. So we're going to do a lot of that kind of stuff this week. So the top's still an x plus 2. That doesn't really matter. We're going to factor the bottom to this. Now, either this or this, if that goes to 0, you're in trouble. So x can't be a 0, or it can't be a -1. A 0 turns this to 0. 0 times this blob is 0. -1 turns this to 0. 0 times -1 is 0. Okay, so we're going to do, like I said, a lot of domain and range stuff. but there's a quick little recap of those. We'll look at some of those problems tomorrow. Last topic we're going to cover tonight are your exponent rules. These are real important. This should be a little review from Algebra 1 and also Algebra 2. We're going to do actually some more difficult ones as well. So if you multiply two things together with the same base, say an x to the 6th and an x to the 5th, you add them together. That's what the rule says. If you divide two things, you subtract them. So if you have an x to the 10th over an x to the 4th, you have an x to the 6th left over. Okay, 10 minus 4. The same way, if you have a 4 over x to the 10, you get x to the negative 6, because think about where those x's are. All 4 of these are going to cancel with 4 of those, and you're left with 6 more. We'll discuss what you do with the negative exponent ones later. Third rule, you got something to a power and then to another power. Okay, that b gets multiplied in there. So an example, x squared cubed, you have 3 groups of x squared. So now if you write it this way, you're back to rule number 1. You can add them all up. You get x to the 6th. If you see this and you use this rule, you multiply in 2 times 3, still gets you to the same thing. Similarly, if you got 2 variables to a power, okay, it's got to go all the way through like this rule here shows. So let's say this is 2y to the 7th. Okay, a lot of people just stop with 2y to the 7th. That 7's got to come all the way in. So 2 to the 7th, y to the 7th. So I think 2 to the 7th is like 128 or whatever, but we can use our calculators. Okay, 5th rule, division to an exponent. You can see how, I don't like how they write the division here, but you can see that that a, again, hits both places. So if you had, say, x squared over y all to the 6th, that 6 is coming in top and bottom. So you'd have x to the 12th all over y to the 6th. 6th rule is the negative one. Anything to a negative exponent, you can rewrite it as 1 over that same thing to a positive. So that could actually bring us up here, and we could write this one this way, 1 over x to the 6th. Okay? If you have 2 to the negative 3rd power, it's not negative 8. It's 1 over 2 to the positive 3rd, which is 1/8. Same way, if you have like 1 over x to the negative 7th, even though the negative exponent's on the bottom, this rule still applies. We take the reciprocal and we make it positive. Last rule, anything to a 0 power is 1, not a 0. So you could even take smiley face to a 0 power, and you better get 1. One problem here on simplifying kind of just a big mess of an expression with a bunch of exponents. So first thing we see, we got an x to the 10th there all by itself, not much you can really do. You got a whole blob to the 3rd. This 3 has got to come into all those places here. On the bottom, 2's by itself. This 7 has got to come into both places there, not all the way over to the 2. So let's see what happens. Let's keep the x to the 10th. So you got a 5 to the 3rd, x to the 12th, y to the negative 6th, because we're multiplying using our rules. On the bottom, 2x to the 7ths, y to the 7ths. Now here you really have some choice. Do you want to simplify the top and simplify the bottom and then see what happens? Or do you just want to kind of take care of this as it comes along? I'm going to look at this and go, I got 7 x's on the bottom, I got 10 of them on the top. That's going to leave me with 3 x's left over. The y to the negative 6th is going to get moved down, and it's going to become y to the positive 6th. Now I got x's on the top that are the same as well. So I'm going to keep the 5 to the 3rd, which is 125. X to the 3rd, x to the 12th is an x to the 15th. This gets moved to the bottom. Copy the 2, x to the 7th's gone. The y to the 7th is there. The y to the 6th swings down. Now those two can be combined together. X to the 15th, 2y to the 13th. And you're done. One last example here, kind of a little bit harder. It's got the division 1 all to a negative exponent. You get two choices. You can ignore this, and you can simplify this, and then come back to the negative 5. Or you can distribute that negative 5 into all the places and then simplify. I'm going to choose to ignore this and try and simplify the inside. I'm going to copy the 2, so that's gone. This a to the negative 2nd, I'm going to move to the bottom as make it a positive. I'm going to keep the b to the 7th on the top. I'm going to keep the 5 on the bottom, putting it in front of the variables. Okay, a to the negative 7th, that's going to get moved to the top and made positive. B to the negative 3 is going to get moved to the top and made positive as well. So now I'm going to look at it and say, okay, the 2 and the 5 are just going to stay. Nothing I can do with those. On the top, I can combine the b's, and then I still have an a left over. I'm actually going to put the a first. So there's going to give me 10 b's there. On the bottom, I got an a squared. I take a look at it again. I got 7 over 2 a's, so I'm going to cancel those out. And that's it. 2a to the 5th, b to the 10th over 5. So kind of a little bit review there for some stuff you guys have done before. Come to class tomorrow, any questions you guys have, and we'll work on these types of problems in class. We'll see you guys tomorrow.